In 1946, Sir Harold Walker, the commander of Britain's naval forces, gave an order to, quote, blow the bloody place up. He was speaking of Heligoland, a North Sea archipelago that belonged to Germany during the Second World War. The Third Reich had one of its largest naval bases there. After the victory, the British government decided to demolish the fort together with the island so that they would never be used against Britain again. The estimated amount of explosives for this was over 62,000 tons. However, it was impossible to gauge the explosion's true power beforehand, as the retreating Germans had left several hundred kilos of unused munitions. On April 18, 1947, the explosion was carried out. It was so powerful that it caused abnormal seismic waves that could be felt over 1,000 kilometers away. It was later listed in the Guinness World Records as the largest non-nuclear detonation ever. But given even such power, the British failed to achieve what they intended to do. The explosion destroyed all the military buildings but didn't affect the islands much. "The Red Cliffs are still standing," read one of the headlines in German mass media. Nonetheless, the British proved one thing: while everybody feared nuclear weapons, regular explosives could sometimes cause no less damage. In this video, you'll find out how can the wish to reduce traveling time destroy an entire city, how can two trains explode without even colliding, and most importantly, which of the powerful non-nuclear explosions could be real record breakers. Often deadly explosions occur in a seemingly most unlikely environment, on the water surface. Only 2 days before the Heligoland explosion, on April 16, 1947, in another corner of the world, there was an explosion that, beyond a doubt, nobody had planned. That day, at around 8 o'clock in the morning, the port of Texas City in the U.S. accepted a French vessel, the SS Grand Camp, formerly known as the SS Benjamin A. Curtis. After the renowned 19th-century judge, he became famous for fighting for African Americans' rights and being ready to go to any length for justice. Ironically, the incident on the vessel that bears his name sparked a prominent event in the history of American jurisprudence: the first class action against the U.S. government. Did the judge's ghost decide to fight for justice even in the afterlife? But while the assumption sounds fantastic, the fault of some absolutely real people was eventually proven. Because as soon as the SS Grand Camp entered port, the longshoremen noticed a smoke plume in one of the ship's holds. They reported it to the captain, but he ordered that no water be used to extinguish the fire so as not to ruin the cargo. Instead, he suggested filling the holds with steam. The captain wanted to raise the humidity to smother the fire. It might have even worked well. That is, if the Grand Camp hadn't been jam-packed with explosive fertilizer. That day, the vessel had over 2,000 tons of ammonium nitrate on board. This particular batch was manufactured in a patented explosives process mixed with clay, petroleum rosin, and paraffin. The method was rather secure, and thanks to it, no chemical processes could occur in the ammonium nitrate unless the environment's temperature rose. But this is exactly what happened after the captain gave the order. At around 9 in the morning, a powerful explosion shook the Texas City port. The shock wave of almost 4.5 m leveled almost 1,000 buildings at once and shattered windows 16 kilometers away. At the same time, Grand Camp's 2-ton anchor was hurled over 2.5 kilometers away. But that was just the beginning. Apart from the dangerous fertilizer, the ship's cargo also contained bales of twine, peanuts, engineering equipment, and even small arms ammunition. In other words, the cargo ship was like a giant Molotov cocktail. Pieces of the burning twine rose so high that 2 sightseeing airplanes had to change their course. Then the flaming pieces showered down on the city. They caused the explosion of several other vessels in the port as well as an oil refinery and some chemical reservoirs. 3/4 of the port workers burned alive. According to official information, the total number of victims, including the exploded ship's crew, was 581 people. But these are only those who were identified. According to one speculation, the explosion took the lives of at least as many more people, including visiting undocumented laborers and a vast number of travelers. However, the next tragedy cast a shade on even such substantial damage, all because of the unfortunate human reluctance to come to terms with one another. In the late 19th century, Halifax, a port town in Canada, faced a serious economic downturn. This was why the Canadian government ruled that all vessels, regardless of their further course, be checked in Halifax. After the beginning of the First World War, this legislation led to a real boost in the port's operations. Among the military convoys arriving in Halifax, there was a Norwegian vessel, the SS IMO, which had to pick up a cargo of relief supplies for Belgium. The ship was scheduled to leave the port by December 5, 1917, but the first issues with communication began. No one told the port workers to load IMO with extra coal for the long voyage, so the crew had to wait until the next morning. And when, on December 6, IMO finally departed from the port, its speed was well above the harbor speed limit. This is how the crew tried to make up for the delay. But it was also when Halifax, overwhelmed with vessels, was accepting another boat, the French cargo ship SS Mont Blanc. Its captain gave a short blast of his ship's signal whistle to indicate that he had the right of way. But the Norwegian vessel returned 2 short blasts, showing it wouldn't yield its position. IMO's crew didn't want to lose another minute and kept steering the ship straight at Mont Blanc. When the distance between them was reduced to 800 m, both ships halted their engines, but they kept moving, carried by inertia. At 8:45 in the morning, one of the most seemingly boring shipwrecks in history occurred. Neither ship's speed exceeded 2 km/h. But the fact that the Mont Blanc was loaded with TNT and highly flammable fuel put the wreck in the annals of record explosions. Several sparks from the slow collision were enough for the French ship to literally soar and burst into pieces in the air. For the following few seconds, the temperature at the detonation site reached about 5,000 degrees Celsius, which is almost as hot as the surface of the sun. The shock wave spread at a speed of over 3,000 km/h that would outpace our most modern fighter jets. This diabolically destructive explosion even exposed the harbor's seabed in its epicenter, having displaced all the water. It also caused an 18 m tall tsunami which washed IMO ashore. At the same time, the hot debris started falling straight on Halifax, taking the lives of those who survived the first wave. More than 1,500 people died as a result of the explosion and around 9,000 were injured. People even heard the terrible Halifax explosion in cities 200 kilometers away from the epicenter. The tragedy was long believed to be the largest explosion in the world. But as technology evolved, sea explosions, which first were absolute record holders, lost the lead. With the reclamation of the sky and especially space, unwanted explosions reached an astronomical scale. The launch of Antares 130, an international space launch vehicle, was scheduled for October 27, 2014. The craft was supposed to deliver over 1,500 kilograms of provisions and precious equipment, as well as 727 kilograms of samples for scientific studies to the ISS crew. But 10 minutes before the mission, an unidentified boat was detected not far away from the spaceport on American Wallops Island. The boat's crew ignored orders to leave the restricted area. It soon turned out that the boat ended up there by accident, but the launch still had to be postponed. It took place exactly 24 hours later, and when everything was finally set and the countdown was given, the rocket suddenly exploded. The structure's debris fell on the launch pad, causing an even stronger detonation. According to the official version, the reason behind the disaster was a malfunction in the rocket's engine. But what actually happened remains a mystery to date. Could it be that while the spaceport employees were distracted by the strange vessel, somebody slipped onto the launch pad and sabotaged the rocket? The losses the accident inflicted were approximately $150 million US, making it one of the most expensive in history. But this explosion at least didn't result in numerous casualties, unlike the next disaster. Various missile systems development greatly benefited from the so-called Cold War, a global confrontation between the Soviet Union and the United States. During that time, both nations began actively working on improving all different kinds of weapons. It was necessary not just for self-defense but rather to show off to each other. Neither party could afford to fall behind in the race. In 1955, the US government presented the first transcontinental ballistic missile in the world, the SM-65 Atlas. Its range was enough to hit some cities in the USSR's European part. To keep the par, the Soviet Union needed to quickly develop its own Atlas analog, preferably possessing even more impressive characteristics. But there was a problem. At that time, the nation didn't even have draft designs of a similar weapon. However, that didn't stop the government. On December 17, 1956, the USSR's Council of Ministers issued a resolution on the development of an intercontinental ballistic missile, the R-16. The work was done at an accelerated pace. The demonstration test of the new weapon at the Baikonur Cosmodrome was scheduled for October 1960, however, the missile wasn't ready by that time. Several structural elements turned out to be defective, so the R-16's launch was postponed until the end of the month. But it wasn't enough to eliminate the issues. The Soviet engineers failed to complete all the tests even by November. To meet the new deadline, they had to refuel the missile with highly toxic and flammable components. Then the engineers had to wait until November 23 to remove the defects. At the same time, Marshal of Artillery Mitrofan Nedelin stayed at the launch site. He ordered to speed up the preparation process. The rocket was fueled and even installed on the launching table. However, several flaws were found in its electronics, but Nedelin didn't want to postpone the launch anymore. The engineers decided to correct the errors at the launch pad, directly inside the fueled rocket. But they failed to get it all done in time. At 6:45 p.m. Moscow time, the electronics gave an impulse that ignited the second stage engine. But the missile remained fixed on the launch table, so the impulse caused an explosion. Its blast wave spread 50 m around the site and engulfed everything in flames. The highly toxic fuel caused even more casualties. In total, 126 people died as a result of the detonation. The explosion's causes were soon established, but the information was classified until 1989. The tragedy went down in history as the Nedelin catastrophe. But as soon as the Soviet Union's rivalry with the United States evolved into a space race, the USSR's most significant missile explosion gave way to an even more massive one. The main rocket used for the Soviet space program was the N-1, a super heavy-lift launch vehicle. It was supposed to send astronauts to the Moon and Mars and even launch orbital stations. But the N-1 had one severe flaw. Its first-stage engines were powered by liquid fuel. The technology was far from perfect, as it turned out. From February 1969 to November 1972, 4 launches of the N-1 took place. But none of them went as planned. This super heavy-lift launch vehicle kept crashing one after another. The most devastating incident happened on July 3, 1969. 23 seconds after launch, the N-1's fuel pump failed, causing a fire on the engine. The rocket fell back on the launch pad and exploded. The shock wave literally knocked the wall out of the blockhouse, which was 1 kilometer away from the epicenter. It was the biggest explosion in space rocket history. The accidents with the N-1 became one of the key factors that made the USSR lose the race to the Moon. The engineers tried to eliminate the design flaws, but the rocket was finally decommissioned in 1976. But while people usually learn from their own mistakes, our space program has seen no fewer tragic incidents. On May 15, 1986, there was a Proton booster rocket launch at Baikonur Cosmodrome. The Soviet Union regularly used this booster to launch different spacecraft. But that time, a human error caused a major disaster. The Cosmodrome employees allowed the fuel to leak, which led to a fire in the second stage engines and an explosion. The second detonation spread to the launch pad and took 92 lives. The human error factor was established, but the information about the accident was kept secret for a long time. The accident became known to the public only after the collapse of the USSR. This is one more example of how people's negligence can lead to truly disastrous results.